హాయ్ ఫ్రెండ్స్, ఈరోజు మనం డయామీటర్స్ ఆఫ్ థ్రోట్ అండ్ ఎగ్జిస్ట్ ఫర్ మ్యాక్సిమం డిశ్చార్జ్ నాజిల్ చూద్దాం. కన్సిడర్ ఏ కన్వర్జెంట్ డైవర్జెంట్ నాజిల్ డిశ్చార్జింగ్ స్టీమ్ యాజ్ షోన్ ఇన్ ఫిగర్. ఇక్కడ చూసుకున్నట్లయితే మనకి ఇది కన్వర్జెంట్ అండ్ డైవర్జెంట్ నాజిల్. ఈ నాజిల్లో స్టీమ్ ఇన్లెట్, steam outlet. This is throat. We need to find out here in throat diameter. Okay, and this is for enthalpy and entropy diagram. For this is entropy and this is enthalpy. ఇక్కడ మనం చూసుకున్నట్లయితే A, B and C. Okay, now in here A to B, B to C. Here look at this. This is inlet H1. Middle of portion is called throat, and now H3. Pressure P1, P2, P3. And now this is called saturation line. Okay, and this is drainage fraction, and this is another drainage fraction for this. Okay, so this is the enthalpy and entropy diagram. Okay, now we will see let P1 is equal to initial pressure of steam, H1 is equal to enthalpy or total heat of steam at inlet, and now here P2, P3, H2, H3, P2, P3, H2, H3, corresponding values at throat and outlet. X2 is equal to drainage fraction of steam at throat. V2 is equal to velocity of steam at throat. Okay, and now here corresponding to pressure P2 from steam tables, therefore A2 is equal to area of throat corresponding to pressure P2 from steam tables. ఈ వాల్యూ వచ్చేసరికి మనం స్టీమ్ టేబుల్స్లో తీసుకోవాలి. ఓకే, A2 is equal to area of throat. Now in here X3, V3, V3, A3 corresponding values at exist, and M is equal to mass of steam discharged. Okay, so this is the total setup of diameters of throat and exist for maximum discharge. So now here first of all find the value of critical pressure P2 as discussed in heart. Okay, now ఇక్కడ మనకి క్రిటికల్ ప్రెషర్ వచ్చేసరికి P2 వచ్చేసరికి మనం ఫ్రమ్ స్టీమ్ టేబుల్స్ నుంచి తీసుకుంటాము. ఇక్కడ మనం చెప్పుకున్నాం ఆల్రెడీ. ఓకే, ఫ్రమ్ స్టీమ్ టేబుల్స్. ఓకే, నౌ కంప్లీట్ ద HS diagram as shown in figure. Now this is the HS diagram we see here. For the expansion of steam function, the convergent divergent nozzle as discussed below. First one, first of all locate the point A for the initial conditions of steam. So now this is initial conditions of steam A. It is a point where saturation line meets the initial pressure P1. This is the saturation line where it will meet the P1. Okay, next, now draw a vertical line through A to B. A to meet the critical pressure P2. The line B at B represents the throat of the nozzle. Now to look at here, pressure P1 to go for pressure P2. That is called the pressure line, saturation line B, point B. Now extend the vertical line AB to meet the outlet pressure P3, a line at C. Now same AB and extend this line B to C. Okay, now this is called here P3, where the AB line is meet at the point is called C. Okay, this representation the outlet of the nozzle. This is called outlet of the nozzle. Now find the values of h1, h2, h3, h4 and x3 from the hs diagram. సో ఈ డయాగ్రామ్ నుంచి మనకి అన్నోన్ వాల్యూస్ ఏవైతే ఉన్నాయో ఆ అన్నోన్ వాల్యూస్ అన్నీ కూడా మనం ఇక్కడ ఫైండ్ అవుట్ చేసుకోవాలన్నమాట. ఫస్ట్ ఆఫ్ ఆల్ కన్సిడర్ ద ఫ్లో ఆఫ్ స్టీమ్ ఫ్రమ్ ద ఇన్లెట్ టు ది throat. We know that enthalpy or heat drop HD2 is equal to H1 minus H2. First we take consider here the steam will be enter inlet to throat. ఇక్కడ నుంచి ఇక్కడ వరకు వెళ్తుందని కన్సిడర్ చేసుకుంటే మనకి ఇక్కడ వచ్చేసరికి ఏంటంటే ఏ నుంచి బి. ఓకే, so the velocity of steam at throat V2 is equal to 44.72 root of HD2. Already we know very well, but here we fix only 2 to why, because here we fix to diameter of the throat. Okay, not for exist. You know that mass of steam discharged by seconds, that's m is equal to volume of steam flowing at the throat divided by volume of 1 kg of steam at pressure P2. Okay, so this is the to find the, now here A2 V2 by V2 is equal to A2 V2 by X2 into G2. Similarly for exist conditions, exist means here, look at this is the exist. Okay, now in here the above equation you can write m is equal to A3 V3 divided by X3 Vg3, that is equal to A2 V2 divided by X2 Vg2. Okay, so now knowing the value of m we can determine the area or diameter of throat and exist. So ఈ విధంగా మనం ఎం వాల్యూ కానీ లేదంటే ఏరియా వాల్యూ కానీ లేదంటే డయామీటర్ వాల్యూ కానీ మనం కనుక్కోవచ్చు అనమాట. ఓకే, సో నౌ వీఆర్ గోయింగ్ టు లుక్ ఎట్ ద ప్రాబ్లమ్ ఫర్ దిస్. ఓకే, లుక్ ఎట్ దిస్ ప్రాబ్లమ్. స్టీమ్ ఎంటర్స్ now steam enters a group of nozzles of a steam turbine at 12 bar and 220 degrees Celsius and leaves at 1.2 bar. The steam turbine develops 220 kilowatts with a specific steam consumption of 13.5 kg per kilowatt hour if the diameter of nozzle at throat is 7 mm. Calculate the number of nozzles. సో ఇక్కడ మనకి నెంబర్ ఆఫ్ నాజిల్స్ అనేవి ఎన్ని ఉన్నాయనేది కనుక్కోవాలంటున్నారు. పవర్ ఈస్ గివెన్, నౌ టెంపరేచర్స్ ఈస్ గివెన్, ప్రెషర్స్ ఈస్ గివెన్. ఓకే, నౌ వీ కెన్ గో టు సాల్వ్ దిస్ ప్రాబ్లమ్. Before going that we are given write the given data. Okay, so solution given. So what is given here? P1 is given 12 bar, T1 is given 220 degrees Celsius. Again here we written here pressure P2 is given, leaves, so 1.2 bar, and now power developed. So power developed capital P is equal to, okay, how much is given? 220 kilowatt is given. Now m is equal to 13.5 kg per kilowatt hour. Now D2 is given, diameter of throat. So before solve this problem we draw the HS diagram in here. Okay, now the point is initial point A, this is called inlet, we know very well. Okay, and now here the saturation point is going like this. So this is called 220 degrees Celsius. Okay, and now this is the point of P1 increasing. Where is the point is touch, that is called we know H1. Now we are going to draw throat for this. Okay, now the pressure will going like this is called P2 pressure. The point is coming from here B, and the saturation line will going like this. And now go for exist, but here we don't discuss any point anything in exist. This is coming from pressure 3. Okay, and now here the saturation line will going occur like this. So this is called saturation line. Okay, now this is the saturation line. Here the point A to B we need to hear, that is the thing. Okay, now go to solve the problem. I know that for superheated steam pressure, now that superheated steam pressure of steam at throat P2 is equal to 0.546 P1 is equal to 0.546 into 12, that is equal to 6.52. Okay, so then here 1.2, this is coming from 1.2. Okay, no, P1. Oh, this is given for 12 bar, so you can write down here 12. Okay, from steam table. Okay, here we know that for superheated steam pressure of steam at throat second, and this is fixed for this all values. Okay, now then we get the P2. Now here we don't write here P, we can take P1. Okay, the Euler diagram, this is the Euler diagram for the expansion of steam through the nozzle is shown figure. From the Euler diagram we find that enthalpy here, this is for H2 enthalpy, and now this is for H3. Okay, of steam at entrance, so H1. Okay, we need to find steam at entrance H1, that is at pressure 6.552 bar. So yeah, here we are going to find enthalpy of steam at entrance, so that is at 12 bar and 220 degrees Celsius. So here, okay, now pressure P1 220 degree Celsius. This is the saturation line for this 220 degrees Celsius. Then from steam tables you can take this. Okay, no, from Euler diagram. Okay, this is taken from Euler diagram. H1 is equal to 2860 kilojoules per kg from Euler diagram. Okay, now enthalpy at throat. Now we are going to find enthalpy of steam at throat. Okay, then you can write here, that is at pressure 6.552 bar. Here we can find out here, this is the value for throat. Okay, so steam at throat. Now the pressure is acting like this, so then we go for here H2. This is the throat. Look at here, enthalpy H2 is throat. Okay, that is equal to 2750 kilojoules per kg. And the dryness fraction of steam at throat. So that is equal to x2 is equal to 0.992. Okay. Now from steam tables, now from steam tables, okay, we find specific volume of dry saturated steam at throat, that is pressure 6.552 bar. Now then here we go to volume. Vg2 is equal to, I can write here, meter cube per kg volume. Okay, now we know that heat drop from entrance to throat. Okay, that is equal to ht2 is equal to h1 minus h2. Then substitute these values. Then we get here heat drop. Okay, now we find the heat drop. Next we go for velocity of steam at throat. Okay, then v2 is equal to 44.72 root of ht2. Then you can find out this. Okay, 470 meter per seconds. Next we go for area of nozzle at throat. Then A2 is equal to pi by 4 d2 whole square, that is equal to pi by 4 into 7 square. Okay, 5 mm. Now here area of the nozzle at the throat. Here velocity it will come. This is the point. Okay, throat point. Here velocity we find out. Now here A2 is equal to throat area. Okay, we find throat area. Now we go for, therefore, mass flow rate per nozzle. That thing m is equal to A2 V2 divided by small v2, that is equal to A2 V2 divided by x2 Vg2. Now substitute the all values in here. Now 0.992 into 0.29. So then we solve this one. We can find out this kg per seconds. Okay, this is the mass flow discharge rate. Okay, but we need to find here total number of nozzles we need to find out here. So then we can go, we know that total mass flow rate. Okay, so the total mass flow rate is equal to 13.5 into 220 is equal to 2970 kg per hour. Now we converted into seconds here. kg per seconds. Okay, now this is the given mass, okay, m into, and this is for temperature 220. Okay, now then we can find out this thing, mass flow rate. Okay, and now here number of nozzle is equal to total mass flow rate divided by mass flow rate per nozzle. Then substitute these values in here, divided by 0.063, that is coming from 13.1. It says approximately 14 number of nozzles can use. Okay, so this is the solution for this problem. Okay, and next remaining some problems we'll discuss next class. Okay, thank you.